When we talk about memory, we, as programmers, like two things. We want our memory to be given back to us at a time of our choosing, and we never want to reference memory once we have given it back to the system, because if we do this, then it causes undefined behavior and can lead to crashes and security holes. In 2019, Microsoft Security Response Center reported that roughly 70% of the vulnerabilities they assigned to a CVE each year continued to be memory safety issues. So memory safety is a big deal. Typically, programming languages have done two options. The first one is garbage collection, which Java, C#, Python, JavaScript, and so on all have. With a garbage collector, programmers give up having control over when objects are freed to the collector. The second is through manual freeing of the memory, such as what is done in C and C++, which is great if you never make a mistake, but history says programmers are likely to make a mistake. So what does Rust use? Well, technically neither. Rust uses an ownership module, and ownership is Rust's most unique feature. Rust compiler is going to verify that your program is free of memory safety errors, such as dangling pointers, double freeze, using uninitialized memory, and so on. This concept is what drives the Rust language, so it is important to understand the reason behind this design choice. So let's start looking at what ownership is, because it is a new concept for most programmers, so it does take time to get used to. But the more you use Rust and become familiar with the rules of ownership, the more natural you will begin to feel with the concept. Let's quickly talk about the stack and the heap, which are parts of memory. The stack is going to store values in the order it gets them and removes the values in the opposite order. So it is a last in, first out. A great example of this is a stack of plates. You add to the top, but then you also remove from the top. All data stored on the stack must have a known fixed size. Data without a known size at compile time or a size that may change will be stored on the heap. The heap is less organized, and when you put something onto the heap, you request the space, and that will then return a pointer, which is the address of that location. Pushing onto the stack is faster than allocating on the heap, so searching for data on the stack is also faster than searching the heap. When you pass values into a function or have local variables inside the function, they are all pushed to the stack. And then when the function is over, they're popped off the stack, which is the same thing as removing them from the stack. So I mentioned earlier the rules of ownership. But what are they? Well, the rules are each value in Rust has a variable called its owner. There can only be one owner at a time. And then when the owner goes out of scope, the value will be dropped, also known as freed. So let's start off with a simple example and just start trying to understand what these concepts mean. So for the first one, we'll say let var equals 1. So in this case, var is now valid for the rest of the main function. And since we know that the value 1 is of I32 or U32, in this case it's I32, it has a fixed size. So we know that we're getting pushed onto the stack. But now, say we're down here now, var is dropped because the main function is over, so we are freed from memory. So same thing with strings. Strings can change in size. So we're going to do a mutable string called s, and we will do hello to string. So now we have the s variable, which is a string called with the data hello, and this is going to be created on the heap. Created on the heap on the stack. So just like down here, now that we are no longer in the main function, s is also dropped, and the resources are given back to the operating system. So now we can push a string on here and just say hello world. And what this is going to do, it's going to append world at the end of hello, which we can do because we are allocated on the heap. And that means we are able to grow. So in the following lectures, we are going to dive into these mechanisms that drive ownership.